Weathering. The disintegration and decay of rocks caused by weather forces such as frost, rain, and temperature changes. What is weathering? Definition. Weathering is the process by which rocks are broken down into smaller fragments by atmospheric forces. Involved factors. It involves the breaking and decaying of rocks caused by climate factors, the nature of rock, relief, and living organisms. 3 types of weathering. Physical/mechanical. Rocks broken down by weather forces without chemical composition changes. Chemical. Decomposition involving chemical reactions that change rock composition. Biological. Weathering caused by activities of living organisms like plants and animals. Physical weathering. The breakdown of rocks by weather forces without changing their chemical composition. Alternate heating and cooling. Daytime heating. Intense solar radiation causes the outer layers of rocks to heat up and expand more rapidly than their cooler, inner parts. This differential expansion generates significant internal stress within the rock structure. Nighttime cooling. As temperatures drop sharply at night, the outer rock layers cool and contract quickly. This repeated cycle of expansion and contraction over time weakens the rock, leading to fatigue and eventual fragmentation. 3 results of temperature stress. Exfoliation. Outer parts peel off like onion layers, forming rounded exfoliation domes. Block disintegration. Rocks break along joints into large regular blocks. Granular disintegration. Multi-mineral rocks like granite break into small, grain-sized pieces. Alternate wetting and drying. Environmental context. This process is common in tropical regions, characterized by heavy rains that saturate rocks, followed by rapid drying under hot sun. It also significantly affects coastal rocks that are repeatedly submerged and exposed due to tides and waves. Mechanism and effect. The repeated cycles of expansion when rocks absorb water and subsequent contraction as they dry create internal stress. This continuous stress eventually causes surface layers of the rock to peel off, contributing to physical weathering. Frost action. Freezing and thawing process. Water in rock cracks freezes at night or during winter, expanding by 10% of normal volume. This exerts pressure on crack walls, forcing rocks apart. When temperature rises, water thaws. Repeated cycles widen and deepen cracks, eventually breaking rocks apart. Chemical weathering. The decomposition of rocks involving chemical reactions that change the chemical composition and coherence of affected rocks. 5 chemical weathering processes. Solution. Minerals dissolve in water, especially acidic water. Oxidation. Oxygen reacts with minerals, causing rusting. Hydrolysis. Water combines with minerals to form new compounds. Hydration. Rocks absorb water and swell, weakening structure. Carbonation. Carbonic acid dissolves calcium carbonate rocks. Carbonation in action. Acid formation. Rainwater absorbs carbon dioxide from the atmosphere, producing weak carbonic acid. This acid is the primary agent for dissolving calcium carbonate rocks. Rock dissolution and removal. The carbonic acid dissolves limestone and other calcium carbonate rocks. The dissolved limestone is then removed by running or percolating water through joints and caves, forming characteristic geological features. Oxidation, the rusting process. When rocks containing iron are exposed to oxygen in air or water, the iron changes from a ferrous to a ferric state. This process, commonly known as rusting, causes blue or gray rocks to turn reddish-brown. Solution and hydrolysis. Solution. Simple process where water-soluble minerals like rock salt dissolve when water is applied. Rate increases with water acidity. Hydrolysis. Hydrogen combines with metal ions, creating new compounds as water reacts with minerals. Biological weathering. Weathering caused by the activities of living organisms including plants, animals, and humans. How living organisms weather rocks. Plant roots. Tree roots grow in cracks and act as wedges, causing rock pieces to break away from the main mass. Animal burrowing. Earthworms and other animals burrow through soil, helping to loosen and break down rock material. Human activities. Road construction, mining and farming activities contribute significantly to rock weathering processes. Factors influencing weathering. 5 major factors determine how quickly and extensively rocks weather in different environments. Climate. Temperature and moisture levels significantly impact chemical and physical weathering rates, with warmer, wetter climates generally accelerating processes. Rock type. The mineral composition and structural characteristics, e.g., fractures, bedding planes, of a rock, dictate its resistance to weathering agents. Topography. Slope angle and elevation influence water runoff, erosion, and exposure to atmospheric elements, affecting weathering intensity. Presence of biota. Living organisms, from microorganisms to large plants and animals, contribute to both mechanical and chemical weathering through various activities. Time. The duration of exposure to weathering agents is a crucial factor. Longer exposure generally leads to more extensive weathering. The 5 key factors. Nature of rocks. Rock composition and structure affect weathering susceptibility. Climate. Temperature, rainfall, and humidity control weathering rates. Relief. Slope and elevation influence weathering processes. Vegetation. Plant cover affects moisture and biological weathering. Human activity. Construction, mining and agriculture accelerate weathering. Climate's powerful influence. Temperature effects. Extreme temperature changes accelerate physical weathering through expansion and contraction cycles. Moisture impact. High rainfall and humidity promote chemical weathering by providing water for chemical reactions. Weathering in action. Understanding weathering helps explain landscape formation, soil development, and geological processes that shape our Earth's surface over time. Chemical weathering. Water and chemical reactions alter rock composition, seen in phenomena like chemically weathered limestone formations. Physical weathering. Mechanisms like frost wedging break rocks apart without changing their chemical makeup, leading to frost-shattered mountain rocks. Biological weathering. Living organisms such as tree roots can exert pressure and produce chemicals that break down rocks, as evidenced by tree roots breaking through pavement. Key takeaways. 3 types. Physical, chemical, and biological weathering work together to break down rocks. Climate matters. Temperature and moisture are the most important factors controlling weathering rates. Shapes, landscapes. Weathering is fundamental to understanding how Earth's surface features form and change.